Hi everybody, so in this video we're going to look at the Weierstrass substitution, also known as the tangent half-angle substitution, and it's used in calculus to evaluate integrals involving rational functions of sine and cosine. It's particularly useful when dealing with integrals of the form the integral of f of sine x and cos x integrated with respect to x, where f is the rational function of sine x and cos x. The substitution essentially transforms the trigonometric functions into algebraic expressions, making it easier to integrate the function. So, if we work for example 1, we've been told to use the substitution that t equals tan of x over 2 to work out this integral. So if t does equal tan of x over 2, then we should know that the cos of x can be written as 1 minus t squared over 1 plus t squared. If you're not sure how to do this, you should check out my videos on the t formulae on my website. So if we substitute this into our integral in place of cos, we've got the integral of 1 over 1 plus 1 minus t squared over 1 plus t squared, integrated with respect to x. But now we've got an integral in terms of t, so we need to change what we're integrating it with respect to. But we can work out dx if we differentiate t. dt by dx, and we should know that the standard derivative of tan is sec squared of x over 2, and using the chain rule this becomes 1/2 of sec squared of x over 2. And we can write sec squared of x over 2 in terms of tan using the identity that sec squared x is equal to tan squared x plus 1. So now we can substitute this into our derivative. So now we can write dt by dx is equal to 1 over 2 times tan squared of x over 2 plus 1. And we know that the tan of x over 2 we've said is t. So dt by dx becomes t squared plus 1 over 2. And now we can make dx the subject, so dx becomes 2 dt over 1 plus t squared. It's really important that we learn this rule because this will help us a lot as we go forward. Okay, so now we've got dx, we can substitute this into our integral. So we have the integral of 1 over, and I'm going to write this one with a common denominator of 1 plus t squared. So we've got 1 plus t squared plus the 1 minus the t squared all over 1 plus t squared. And now this dx becomes 2 over 1 plus t squared dt. Now we can tidy up this denominator and we can reciprocate this fraction because it's 1 over. So this becomes the integral of 1 plus t squared over 1 plus 1 is 2 and these t squareds will cancel. 2 times 2 over 1 plus t squared, integrated now with respect to t. We can see this 2 will cancel with this 2, and this 1 plus t squared will cancel with this one. So all we're working out is the integral of dt, which is t plus the constant. But we know that t is the tan of x over 2 plus the constant, so this becomes our integral. Okay? Let's move on to example 2. Okay, so in example 2, we've been asked to use the substitution again that t is tan of x over 2 to work out this integral. So again, we can use our t formulae. So the sine of x will be 2t over 1 plus t squared, and the cos of x will be 1 minus t squared over 1 plus t squared. And we can substitute each of these into our integral. So we have the integral of 1 over 1 plus sine x, 2t over 1 plus t squared, plus cos x, 1 minus t squared over 1 plus t squared. Again, this is integrated with respect to x. And if we go through the same process as we did previously, dx becomes 2 dt over 1 plus t squared. So now we can substitute this into here. And I'll write this as 2 over 1 plus t squared dt. So now we need to work with this denominator. I'm going to write all over the common denominator of 1 plus t squared. So we have the integral of 1 over 1 plus t squared plus the 2t plus 1 minus t squared all over 1 plus t squared multiplied by 2 over 1 plus t squared integrated with respect to t. And now I'm going to reciprocate this fraction and we'll tidy up this numerator here. So we've got 1 plus t squared over 1 plus 1 will make 2. This t squared will cancel with this one. So 2 plus 2t multiplied by 2 over 1 plus t squared and then dt. We can simplify this fraction further by factoring out the 2. So we've got the integral of 1 plus t squared over 2 lots of 1 plus t multiplied by 2 over 1 plus t squared dt. And then we can see this 2 will cancel with this 2 and this 1 plus t squared will cancel with this one. So what we're left with is the integral of 1 over 1 plus t integrated with respect to t. And this is a standard integral, which is the natural log of 1 plus t plus the constant. And we know that this t is the tan of x over 2. So 1 plus tan of x over 2 plus the constant. And this would be our integral, okay? So in example 3, we're going to look at using limits. Okay, so for example 3, we've been asked to use the substitution again, that t is tan of x over 2, to work out this integral. Okay, so for this example, there's a couple of things we need to do. We need to change our limits, so they're written in terms of t, not as they currently are in terms of x. We need to change the dx to a dt, and we need to write sine and cos squared using our t formulae. So if we begin with these limits, we know that t is the tan of x over 2, and we're told here that t is pi over 2. So the t value will be the tan of pi over 2 divided by 2. This is the tan of pi over 4, which is 1. And then we have the t is the tan of pi over 3 divided by 2. So this is pi over 6. And this gives us 1 over root 3. So now we have our limits in terms of t. We'll have the 1 which is a greater value on the top, 1 over root 3 on the bottom. The sine of x we know is 2t over 1 plus t squared over the 1 plus cos squared x. But if cos x is 1 minus t squared over 1 plus t squared, I can square each the numerator and the denominator. So 1 minus t squared over 1 plus t squared, all squared, times dx. And we know dx is 2 over 1 plus t squared dt. So now we need to tidy this up. And the first thing I need to do is to write this 1 with a common denominator as this fraction. So we'll have the integral of 1 over 1 plus root 3 of 2t over 1 plus t squared all over 1 plus t squared all squared plus 1 minus t squared all squared over 1 plus t squared all squared. And this is multiplied by 2 over 1 plus t squared and integrated with respect to t. So I'm going to simplify this numerator over here, we have 1 plus t squared all squared plus 1 minus t squared all squared. So this becomes 1 plus 2t squared plus t to the 4 plus 1 minus 2t squared plus t to the 4. This one will cancel with this one, so we're left with 2 plus 2t to the 4, which we can factorise as 2 lots of 1 plus t to the 4. And now I can substitute this into here. So we have the integral between the limits of 1 and 1 over root 3. I'm going to write in this fraction 2t over 1 plus t squared. I'm going to reciprocate the simplified version of this fraction, so multiplied by 1 plus t squared all squared over 2 lots of 1 plus t squared, t to the 4, and then multiplied by 2 over 1 plus t squared dt. So now we can see that this 2 will cancel with this one, this 1 plus t squared will cancel with one of these, and this 1 plus t squared will cancel with this one. So what we're left with is the 2, which I can pull out in front of our integral between the limits. Then we've got the t over 1 plus t to the 4, integrated with respect to t. Now we can evaluate this using substitution. So if we let u equal t squared, then when we differentiate t squared, we'll get a t term, and that will cancel with this one. So now we need to work out dt in terms of u. Well, du over dt is 2t, so dt becomes du over 2t. Then we can substitute each of these into our integral. So now we get 2 lots of the integral between our limits of t over 1 plus t to the 4, which is u squared, times dt, which is du over 2t. Now you can see this t will cancel with this one, and this division of 2 will cancel with this multiplication of 2. So now we have the integral between the limits in terms of t of 1 over 1 plus u squared, integrated with respect to u. And this is a standard integral given in the formula booklet, which is the arctan of u between our limits. But we know u is t squared, so we can write this as the arctan of t squared between our limits. So now we can substitute in our limits, and we get the arctan of 1 squared minus the arctan of 1 over root 3 squared, which is 1/3. Well, the arctan of 1 is pi over 4, and the arctan of 1 over 3 is 0.3218. We can work this out on our calculators, and we get 0.4636. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that useful, please like and subscribe, and you can download the full lesson and worksheet on my website. Thanks again, and take care.